Okay, so the last thing we're going to look at for solving triangles this week is the law of cosines. Remember the three types of triangles that you can use law of sines for. Side angle, 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 side angle, side, side angle. There's two other types we haven't studied yet. That's SAS and SSS. And we haven't looked at them because the law of sines doesn't work. That's where the law of cosines is going to come in. So, a side angle side problem would look like that. You'd be given two sides and an angle. But the difference between what we did yesterday when we had two sides of an angle is the angle this time is where the two sides meet. Okay? That makes it side angle side. It also means when you set up your table, sides, angles, you would have two sides and an angle, maybe something like this. Side, side, and an angle. Where I just put the marks, do you have a full row anywhere? No. And the problem is if you don't have a full row, it doesn't work.
Yeah, just do the Hager theorem to...
On a triangle like that.
Yeah.
Nope. Why can't you do Pythagorean theorem?
For right triangle.
That's only for right triangles.
Oh, yeah.
So the problem with law of sines is you have to use two rows from the table. And out of the two rows you pick, you have to know 3 out of 4 of the things. Well, if you pick the first 2 rows, you only know 2 things. If you say, all right, I'll try the second 2 rows, you still only know 2 things. If you say, all right, I'll try the last combination, the first row and the third row, you still only know 2 things. So you don't have a full row. It doesn't work. And we run into the same problem with side, side, side. Side, 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 you have all 3 sides. You don't have a full row. Okay, so this is where the law of cosines comes in. I'm going to show you what the law is, and then we're going to try one example of a side angle side. We'll do one example of side, 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 and then we'll do one word problem. And that's it. Okay. So those are the kinds of triangles we're going to look at today. All right, so we want to solve that. I'm just showing you the problem real quick, but I gotta show you what the law of cosines is, which apparently I'm going to do right as I do this problem. Okay, so first of all, does everybody see why law of sines wouldn't work? Now, if you're still not sure, for some reason, you could always make a sketch. And if it comes out as this or this, then you know you're using law of cosines. Here's A, here's alpha, here's B, here's beta, here's C, here's gamma. Which of the 2 types is this one? Yep, this is side angle side, which we just said has to be law of cosines. So I'm going to show you what the law of cosines is, and then we'll come back to do this problem. So law of cosines. It looks a lot like the Pythagorean theorem with how it starts out. C squared equals A squared plus B squared. But we know the Pythagorean theorem can only be used on right triangles. So it starts out like that, but then we have to subtract something. The something that you subtract accounts for the fact that it's not a right triangle. And what you subtract is twice the product of the 2 sides that you just wrote down, A, B, times the cosine of the angle that's across from the letter you started with. What angle is across from C? Yes, and what's the name of that in general? Gamma. Now, you can write the law of cosines 3 different ways. The pattern of the formula is the same every time. The pattern is always one side squared equals the sum of the other two minus twice the product of the other two times cosine of the angle across from what you started. The pattern that I just said to you in words is more important than actual letters. Because you may have a word problem that doesn't use the letters A, B, C. So then if you're stuck using A, B, C and that's all you know how to do, you're going to get confused when it's not an A, a B, or a C. So based on the pattern, what do you think you would put in these two spots? B what?
B squared equals B squared plus A squared.
Yep, B squared equals A squared plus C squared minus what would come next? Jerry?
2CA.
Yep, I'm just doing it in alphabetical order. So 2AC. And what's the last thing?
Beta.
Times cosine beta. That's not a different formula. It's the same formula. You're just doing different sides. And then how about the version starting with A squared? Yep. And if you did it with x, y, and z, you could say x squared equals y squared plus z squared minus 2yz cosine of whatever angles across from x. So understanding the pattern to the formula is what's more important, rather than trying to write it with every possible letter in the English alphabet. Okay, so now we're ready to look at this example. Now, out of these three versions, there's only one of them that you can use here. If you look at the formulas, every single formula, Law of Cosines has every side in it, no matter how you write it. Every single version has an A, a B, and a C. Well, you're already missing C. So you can't be missing anything else when you pick which version to use. So would we use version 1, 2, or 3 to start this problem off? Here? Yes. You've got to use version 1 because that's the version that has the angle that you know. Anytime you're doing a Law of Cosines problem, your first step is to find all missing sides. Second step, angles. You have to do sides first. Then you can do whatever angles you want. So let's use version 1. And we'll do a couple things as we go. So c squared equals, what's a squared?
4 squared.
Yep, which is 16 plus b squared, which is 49, minus 2 times a times b. 2 times 4 times 7 times the cosine of the angle across from the letter we started with. We started with c, so I want cosine gamma, cosine 42. Okay. And now you have to do all that arithmetic out on the right, following PEMDAS. 40. I wrote 42 instead of 49. Oh, thank you. Yeah, it's important. Okay, so now let's go through and follow PEMDAS. What's the first thing that we should do on the right-hand side if we're following order of operations? Multiply. Okay. Don't worry about the 16 plus 49 yet. We need 2 times 4 times 7 times cosine 42. Well, most of that we can do without a calculator. What's 2 times 4? Times 7? So 56 cosine 42. 56 cosine 42. Check that I'm in degrees. Yep. That's minus 41.616. Now, the next thing after the m in PEMDAS is addition and subtraction. We just go in order from left to right.
Isn't the cosine 42 be 49?
cosine of 42. So that's why I think I messed up the 49, because I was looking at the 42. Okay, so let's do that. 16 plus 49 minus 41,616 gives me 23.384. And what would be my my last step to get C by itself? Yep.
The square root.
Take the square root. So square root of 23.384 is 4.836. Okay, so let's copy that in the box. 4.836. Any questions on how we got C? Okay, now let's put that in our diagram and see what just happened. Okay, so this was a side angle side triangle. That's what was given. What other kind of triangle is it now that I know side C? It was SAS. But now it's also
SF.
it's also SSS, and it's one other type too. Yeah.
SSA.
Yes. SSA or SSA, however you want to think of it. If we think of this problem as side, side, side now, we just change how we're thinking about it. What law does side, side, side fall under? Yep.
Side is law of cosines.
It's still law of cosines. If you think of it from this perspective, side, side, angle, what law is that? That's law of sines. But the problem with side, side, angle is we have to deal with the two solution, no solution, one solution. So we want to stay away from side, side, angle. So we don't have to deal with all that stuff we did yesterday. So if you start a problem with law of cosines, finish it that way. I'm not saying you couldn't use law of sines here if you were very careful. You could. But there's less things to mess up if you just do law of cosines one more time. Okay? So, when you're using law of cosines, there's really only two things that can happen. You guys just saw the first thing. That's solving for a side. Now we're going to use law of cosines, and we're going to solve for an angle. Once you have all the sides, you can find any angle you want, alpha or beta. So which angle do you want to try to find now? Beta? So we're going to find, this was to find C. Now we're going to find beta. Okay, so to find beta, you use what we're calling version 2. B squared equals A squared plus C squared. Well, B squared is 49 equals A squared, which is 16, plus C squared. Well, what's C squared? Shouldn't really have to do any work to find that, yeah? C squared is 23.384. We already had that work done from the previous step. So just use that, 23.384. Minus 2 times A times C. Now for this, we're going to need a calculator. What's 2 times A? What's A? Equals 8. 2 times 4 is 8 times C. Yeah. Yeah.
38.688.
38.688. And that's times the cosine of the angle you're looking for. Okay, Now, this is different than what we did last time. Last time, the variable was basically by itself already, the whole problem, except for the square. But the variable was on the left, all the numbers were on the right. This time, the variable has almost everything with it. All of this stuff needs to go to the other side. But there is some like terms we can deal with first. What are my like terms that I could deal with on the right-hand side?
23.384.
Yes, 16 plus 23.384. And if you add 16 to 23, what do you get? 39.384 minus 38.688 cosine beta. That's our beta. Okay, now at this step you gotta be careful. What would you do next to get beta by itself?
39.384. 40.
Yes, move the 39 to the other side. Sometimes at this step people say, well, can't you do 39 minus 38? No. You can't, because think of it like this. Pretend it was 49 equals 39 minus 38x. The 38 is multiplied by something you don't know. So 39 and 38 are not like terms, any more than you could do 39 minus 38 right there. So bring the 39 to the other side. So minus, and that's going to be 9.6, I don't know, something. 49 minus 39.384, so 9.616 equals negative 38.688 cosine beta. Okay. What would be my second to last step to get beta by itself? Zach?
Divide by 38.688.
Can you just say it one more time?
Divide by 38.688.
And what else?
Then arc cosine.
So that's going to be last, but something else you have to divide by with the 38. What else is in front of the 38? So divide by negative 38.688. 38.688. That's gone. Now, before you go any further, you should look at that, and the bigger number, well, if you pretend like it's absolute value, the bigger number should always be in the bottom. Because this fraction, in order for you to be able to do inverse cosine, has to be between negative 1 and 1. So if you had a fraction like this, that's not going to work. Because if you divide that out, it's not between negative 1 and 1. This will be between negative 1 and 1 because 38 is bigger than 9. It'll be negative, but that's fine. All right, so now Zach told us the last step. We're going to do inverse cosine on each side. And that will get rid of cosine on the right. So 9.616 over that equals beta. Okay, second inverse cosine, 9.616 divided by negative 38.688. And that's going to give you 104.392. And that's beta. Okay, any question on steps to get beta? All right, so now we've got beta and we've got gamma. How could we get alpha?
Subtract beta and gamma from 180.
Yeah, just do 180 minus 42 minus 104.392. So that means alpha would be 33.608. And that, I think, is the harder of the law of cosines because you have to do it both ways. You have to find a side the first time, you have to find an angle the second time. When we do side, 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 you're doing the same thing every time. You're always finding an angle. You're never finding a side. So notice when we found the side, there's no inverse trig in any of those 4 steps. The only time you use inverse trig is if you're solving for an angle. And that should have said inverse cosine. Okay, so let's look at this one. This, I think, is one of the most obvious ones to tell what kind of triangle it is. It's side, side, side. You don't really need a sketch to figure that out. And side, side, side falls under which law? Yep, law of cosines. So we're going to look at doing law of cosines at a minimum. How many times here? Twice. You have to do it twice. You could do it a third time, and the advantage of doing it 3 times is you could find alpha, beta, and gamma totally separate, going back to the information that was given each time. So that means you could mess up one of them and not mess up anything else. Because the way I would grade a question like this on the test, this would be 3 separate questions. Each answer would be counted as its own question. Okay, so let's just pick an angle to solve for first. Alpha, beta, or gamma. We just did beta, so maybe we should try something. Yeah? Alpha. Okay. How does the law of cosines start out to find alpha? A squared, all right, equals
B squared.
B squared plus C squared.
Minus 2BC.
2BC. Let's do 2CB because the arithmetic's easier. What's 2 times C?
10.
Times 7?
7.
70. Cosine of what angle are we trying to find? Alpha. Right. So combine your like terms. 49 and 25 gives me 74. Minus 70 cosine alpha. And Sam, what would my next step be?
It would be combine 74 and 70. Or actually, no. Bring the 74 over.
Yes, 70 and 74 are not like terms, so bring the 74 over. And if you do that, what's 81 minus 74? 7. Okay, second to last step. About Chris? Tell me my next step.
Both sides.
You can, but if you add 70 to both sides, you're going to get 77 equals negative 70 cosine alpha plus 70. Because you cannot combine this with a number because it's not a number. So adding 70 to both sides won't help. Not sure. Okay. Divide by negative 70. That's gone. Divide by negative 70. Don't even worry about reducing that because you're just going to type it into the calculator anyway. So 7 divided by negative 70 equals cosine alpha. But now we want alpha. So what am I going to do on each side? Yep. take the inverse cosine, and take the inverse cosine. Okay, so we'll type that in. Bigger number is in the bottom. So that's when I say bigger, I mean if you divide this out, it's a fraction that's less than 1, right? Specifically, this one's negative. So inverse cosine of 7 over negative 70. Inverse cosine of 7 divided by negative 7. Right, it's 95.739. And you'd have to do the same thing one more time for beta or gamma, and then you could add them up and subtract from 180. So is there any question on how you would do these steps one more time to get beta or gamma? Now, can anybody think of a kind of triangle where you could do law of cosines once and you'd be done? What would have to happen in terms of side, 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 where you could do it once and that would be it? Yep.
0.
Well, none of the sides could be 0, right? Because they all have to be at least a positive number. Yep.
Maybe if the angle you found was 90.
If the angle we found was 90, that would just mean you could use Sakatoa to finish it.
That means you wouldn't have to use the law of cosine.
Yes, that's true. So you're right. I guess if it was that 90, you could use Sakatoa to finish it. But anybody think of another problem where it comes out to an angle that's not 90, but you still don't have to do law of cosines again? Very basic arithmetic is all that would be left. Not necessarily. It has something to do with the sides that would be given to you.
Oh.
Yep.
They were all the same length.
Well, if they were all the same length, what would that mean?
Oh, the angles would be the same.
All the angles would have to be the same, which would mean they would all be what? They would all be 60. So if all the sides are the same, it's equilateral, you don't even have to do law of cosines at all. But we're on the right track if it was isosceles. Because if you had two sides that were the same, all you'd have to do is find one of those angles, and then the other angle would be the same. And then you could add up and subtract from 180. So in an isosceles triangle, you could get away with just doing law of cosines one time. Okay, but this is scaling. In scaling, you always have to do it twice. Okay, so any questions on a law of cosines? So the next thing we're going to look at is how you find the area of a triangle. But one of the formulas, and you're probably used to one of the basic formulas. I'm going to show you a different formula you can use. And one of the formulas I show you comes from the law of cosines. We don't go through the proof. That's kind of lengthy. But I will tell you when we do the formula that this formula comes from law of cosines. So that's the connection. All right. So do I want to do area of a triangle first or the word problem? You know what? I jumped ahead a little. We'll do the area thing next. Let's finish off the law of cosines with a word problem, and then we'll be done and do the area. Okay, so this one says that a surveyor wants to find the distance between 2 points on opposite sides of a building. So let me show you guys the diagram. You had one kind of like this in the homework last night, where they gave you the diagram, and they tell you angle ACB is 54 degrees. So A and B are on opposite sides of a building. Or you can imagine whatever you want. There's an obstruction between points A and B. Maybe it's a lake. I don't know. But for whatever reason, you can't just measure the distance from A to B. Maybe it's like a canyon, and you're finding the distance across the canyon. So surveyor sets up their equipment. The surveyor is at point C, which is on the bottom of your diagram. And the distance from point A to point C is 110 feet, and the distance from point B to point C is 160 feet. And the surveyor, from where they're standing, measures the angle between those 2 points to be 54 degrees. So, the question is to find the distance between points A and B. What kind of triangle is this in terms of the 3 letters? Yep. It's side angle side, which falls under what law? What is it? Yep, it's law of cosines. So let's they already used A, B, and C for the angles, right? So this is why I told you it's important to just understand the pattern. Let's call this side X. So let's set up law of cosines using the pattern 1 side squared equals the sum of the other 2 minus twice the other 2 times the cosine across from what you started with. So when I set this up, what letter am I going to start with?
X squared.
Yep. So 1 side squared equals, what's going to come next? Yep. Plus. So 1 side squared equals the sum of the other 2 squared minus, someone else tell me what's going to come right after the minus. Yeah.
2 times 110 times 160.
Yep. 2 times the product of the sides that you just used before it times the cosine of what's across from x? 54. So now we're going to get some big numbers here, but we're just going to type that all in and see what we got. Does anybody have any of those? Yeah. What's 110 squared? Yeah. 12,100. And how about 16 squared? Is that 25,600?
Yeah.
25,600 minus that one I can't do. 2 times 110 times 160 times cosine 54. What do you get if you multiply those 4 things together? Yep.
35,200.
35,000 exactly.
Oh,
Let's-
goes.
Yeah, whole thing. Whole thing I have underlined. 2 times 110 times 160 cosine 54.
20,690.04.
And what was this? Did you hear 20
20690.
and the decimal?
0.041.
0.04. All right, score that. Okay, so now we can add those up. 12,100, 25,600. What does that add up to? Yep.
37,700.
So 37.7 minus 20,690.04. I'm just going to leave that like that for this step. What's going to be my last step to get x by itself? Chris? Square root. X is the square root of 37,700 minus 27,690.04. Okay. And does anyone have what that comes out to? Yep.
130.42.
130.42.
Yeah.
Right, and that would be in feet. So that's the distance between A and B. Okay, so any questions on that? Okay, so now we'll look at the last thing, which I had jumped a little bit ahead to, which is the law, which is the area of a triangle. So I'm going to show you guys two ways to find the area of a triangle, besides the way you already know. The first way doesn't really have a direct connection at all with law of sines. The second formula I show you comes from the law of cosines. Okay? So that's the connection here. The second formula for area of a triangle, the proof of it, uses the law of cosines. Okay, but we don't go through the proof. All right, so let's take a look at this triangle, and I actually have more labeled in this picture than I need at the moment. We can leave it labeled, I guess. What's the formula for area of a triangle that you learn in geometry? Basic formula. Yep, exactly. 1/2 the base times the height. That formula works great as long as you know the base and you know the height. But if I give you a triangle like this, you don't know the base or the height. Well, I mean, you know the base is 12, but you don't know the height. The height's not 3, because that's slanted. The height would be straight up and down. Okay? So, let's take a look at what we can do if we don't know the height. I'm going to focus on 3 things that I just circled in red. I told you I have extra things labeled here that I'm not going to use. I'm not going to use the A or the gamma. So, I've labeled a triangle. The dotted line H stands for height. A is across from alpha. C is across from gamma. I didn't even label beta because I don't need it. What's the name of this side from the perspective of alpha? That's opposite. How about this side? Hypotenuse. What trig function has opposite and hypotenuse in it? Sine. So sine of alpha equals opposite over hypotenuse. H over C. Now, what I'd like to have is a formula for just H. So what would be in this box based on the formula up above?
C sine alpha.
C sine alpha. So we just came up with a formula that calculates the height. So fill that in for height, and there's a new formula for the area of a triangle. 1/2 base times C sine alpha. 1/2 BC sine alpha. And that's exactly what I just wrote right there. Now, like the law of cosines, if you see the pattern here, you can write this formula 3 different ways, depending on what 2 sides you want to use. So, look at your triangle. A, B, C, alpha, beta, gamma. Look at the 2 sides and look at the angle. Where is the angle that I used in relation to B and C? Yeah.
Adjacent hypotenuse.
You're not going to be able to use one of those words to really, well, yes, I kind of know what you mean, but this is not a right triangle.
Oh.
So we can't really use those words. Like if you just had to describe it using like anybody would describe it, even somebody like not in a math class. Where is this angle in relation to those 2 sides? Yeah,
Between them.
it's between them. That angle is between them. So this formula in general is 1/2 the product of 2 sides times the sine of the angle between them. So what if I wrote it that way? 1/2 the product of 2 sides times the sine of, what's the top angle going to be right there? Yeah, beta. And the bottom one? Yeah. Again, it's not important to try to write this down with every single letter in the English alphabet, because we could write it lots of different ways. What's important is what you see right there. And this is all based on what we did right here, when we used right triangle trig and we substituted in for the height. We got a formula that showed us a pattern, and we're just extending the pattern to other sides. Okay. So area of a triangle is 1/2 the product of the two sides times the sine of the angle between the sides. Now, this particular formula has no connection with law of cosines. It's the next formula that does. So the only reason I'm covering this formula is because it's very easy, and it's in the same section as the other formula. So here's a triangle, and I want to find the area. Now, you can't really say which version of the formula you're going to use here. Is it the BC, the AC, or the AB version? Who knows? Because none of the sides are labeled with letters. So don't worry about the fact that you don't have any letters. Just plug those numbers into that concept, and that will tell you the answer. So, to find the area of this triangle, if I knew the base and the height, I'd just do it how I learned in geometry. 1/2 base times height. I don't know the height, so let's use the new formula. What would I write down in that box to find the area of this triangle? Chris? Well, start at the beginning of the formula. Yep, 1/2. Yep. Yep. Perfect. There's your formula. And let's do what we can before we type it in. 3 times 12 is 36. What's half of 36? 18 sine 105. So the area of that triangle is 17.39 square units. 17.39. Make sure you put square units because it's an area. We don't know what the units are. Okay. Any question on that one? So it's a different, that's the first way I'm going to show you how to, that's different, you can find the area of a triangle. Now, this problem, don't copy it yet because I'm going to show you a shortcut. But technically, you could do this problem. If this was 9, this isn't to scale. Let's say this is 7, 9, 5. How could you use the formula that I just taught you and something else we learned this week to find the area of that triangle? Yep.
Find the law of cosine, or use the law of cosines to find the angle between two of the sides.
Does it matter which angle?
No.
Nope. Use the law of cosines, just like we did on this problem. Find one of the angles, and then use the formula that I just showed you. You could do it that way. So technically, I don't need to show you anything else to do this problem. But there is a shorter way. The shorter way doesn't involve using the law of cosines to find an angle. The shorter way is called Heron's formula. And Heron's formula is used to find the area of a triangle when you know sides A, B, and C. So A, B, and C are the sides. But there's another letter here we've never seen before in the context of formulas this week. The letter S. Well, S is that. And once I kind of tell you what that is, it'll make sense why they use the letter S. What does A plus B plus C tell you if you add up all the sides in a triangle? It tells you the what? The perimeter. If you take half of it, we call that the semi-perimeter. So S stands for the semi-perimeter. And the formula, again, try to think of this in general. It's the square root of S times S minus every side. You got to do S minus A, S minus B, S minus C. So does it really matter which side is A, which side is B, and which side is C? No. Because you got to do S minus every one of them. So if I gave you guys a problem like this, it shouldn't matter. Even though you don't know which side is which now, it shouldn't really make a difference. You can still use that formula. Call each side whatever you want, that doesn't matter. So let's start with S. What's the perimeter if you add up all those sides? Okay. 21, and then take half of it is 10.5. So now, let's find the area. What was the first thing that I wrote down in the area problem? Everything is underneath this. Yep. Yep, so we get the square root of, and Nakira, what's the first thing under the root? S. So that's 10.5. Now we need S minus one side, S minus the other side, S minus the other side. Doesn't matter which ones are which. So let's just go right in order. What's S minus 9? Oh, 1.5. Now we got to do S minus the next side. Kea, what's S minus 7? Yep, 3.5. And Chris, what's S minus the last side? 5.5. And now just type it in. And that's the area of your triangle. You don't have to do any of that multiplication out. Just type square root of 10.5 times 1.5 times 3.5 times 5.5. 17.41. And because it's area, what kind of label should I have? Yep, square units. So again, connection with law of cosines is that this formula, Heron's formula, comes from the law of cosines. The proof of it is just not something that we do in this class. If you forget Heron's formula on the test and you don't have a reference sheet, you can always get around this as long as you remember law of cosines. You could find one of the angles and then do it the first way I showed you. But that'll take a little longer. Okay. Any questions on that? All right, so the homework for tonight is going to be test, take home. That's part 1. Part 2 will be in class tomorrow. Part 1 is due at, so let's see, we have class tomorrow, third period, so that's 9:15 to 10 o'clock, so we'll say like 9:20. So part 1 is due at 9:20 a.m. on 3/13 tomorrow. Okay. Make sure you give tests directly to me. Don't put it under my door and say, oh, I finished it and study, and then I put it under your door, but you must have left Thursday afternoon or something. Because if you put it under my door and it's gone when I come in, then it's gone. So make sure you give the test directly to me.
Just do it at the beginning of your class.
Yeah, because we'll have class at 9 by 9:20. So give the test directly to me. If absent, test is still due by the deadline. So if you are absent, that means you would have to either take a picture of your test and email it to me before 9:20, or scan it, email it to me before 9:20. If you take a picture tonight and then you remember Saturday morning to email it to me, that won't count. Okay, so you've got to email it to me by 9:20. If that's a concern for anybody and they're like, you know what, I'm going to be absent tomorrow and I don't have any way to get you the test by 9:20, that's fine. You don't have to take the test. You can do it in class instead of as a take-home. Right? And I would have to do it a different day because you're not going to have enough time in class. So you could do it after school. You could do it during your shop week. Is the absent part a concern for anybody that's here today? Like being absent and just not being able to get it to me.
Just send a picture.
You can send a picture tonight if you want. Yep. Or if you're going to be here tomorrow, you can just bring it. That's fine too.
Just to be safe.
To be safe. Yep. No concerns from anybody about that? Okay.